Okay, let's write our first program in Java. So every Java program has to begin with a class. So we're going to type public class, and then we name classes so that they begin with a capital letter, and they should usually describe what the class purpose is, or its function, or what it's holding. So my first program is going to be to print a hello message. So I'm going to call this public class hello message. Okay, then after we declare a class, we're going to have code that goes in that class. We want to group that block of code inside of an open and closed brace. Now, the open brace can be on the same line, right, as your class declaration, or it can be at the start of the next line of your class declaration. It really doesn't matter. That's just a personal preference or a convention that a team of coders decides on. I usually will put it at the start of the next line, and I'll make sure that my open and closed braces for the class are parallel with each other. And you'll notice when you hover over it in the IDE, it highlights both so that you can make sure you always have an open and a close. Okay, then next, our program is going to need the main method. So we're going to have public again, then static, which means there's just one instance of the method. Void is the return type. So this method, the main method, never returns anything. So public, static, void. Then the name of the method is main. And then in parentheses, after main, the method name, we're going to have a data type, so string with a capital S, then an open close bracket, which indicates an array, and then args for arguments, and then we're going to have an open close brace again because we want to put our code for this main method inside the open and close brace. Now I'm gonna have my open brace be lined up with my main method declaration. And did you see when I hit enter, I'm gonna hit delete again and go back up. In the IDE, as soon as I hit enter there, it automatically lines it up for me. And that's really nice. It keeps things neat and organized. And then same thing when I press enter, right, to give myself some spaces to type code, the IDE is going to keep that open and close brace parallel, right? Just makes your code more readable. Okay, now inside the main method, I'm going to tell the program what I want it to do. So I'm going to try to print a hello message to the console, and that's done by typing system. System is a class that we're going to invoke, so we have a capital S for the class, then dot, and we're going to output this hello message, so we're going to do dot out. Then we want to print it to the console, and that's the print function, or print method, rather. Okay, what we print will go inside the parentheses of that function, and then we'll close the command with a semicolon. Okay, what I want to print is going to go inside the parentheses, and I could print a number. I could print a number operation like 2 plus 5, but this I'm going to print, I want to print the word hello. So to print a word, I need a string, and strings are indicated with an open and closed quotation mark. So between those quotation marks, whatever I type, see how the word hello is a different color, right? That's because it's a string. So I'm going to say hello to the world, hello world. And hello world inside those quotation marks is blue to indicate that it's a string. All those characters are being grouped together and stored as one data item, if you will. Okay? So now, before we can actually have Java execute this program, it has to be saved. So we're going to go up and hit this save icon, and I'm going to save it in a place where we can look at it. So let's go to Documents, and then we'll put it in this new folder. Okay, and it's going to save with the file name hellomessage.java. That file name has to be the same as the class name. Okay, there can't be any mismatch between the file name and the class name, or it won't work. So I'll go ahead and hit save, and then let's look at the folder. So in my folder, now here's my program, hellomessage.java. Okay, before we can run this program, we first have to do something called compile. And we compile so that the IDE can translate our Java code into machine language that the computer can understand. And we compile using this green plus sign on the IDE toolbar. So we're going to hit the plus sign, and then down here in the console we can see operation complete. Now if we go back to that file folder where I stored the Java file, notice now a class file has appeared. It has the same name as the class that we wrote in the Java file, but now instead of .java, it's a .class extension. Okay, that's the translated machine language file that the computer is going to read when we run our program. So now that we've compiled and there are no errors, we can hit this little red running man here, and that's going to run our program. And when we run the program, Java looks inside the class for the main method, and it starts with the very first line in that main method. So that's the order that it's going to follow. Okay, so we just output hello world in our program. Okay, if I had made a mistake, so let's say I forgot that semicolon. Okay, when I go and compile with that green plus sign, notice down in the console it reports, hey wait, you have an error. There's one error, and it even anticipates for us what it thinks that error is. It says we were expecting a semicolon, and there's a little arrow showing where it thinks that it should go. So your IDE can be very helpful when you need to debug your code. If we were to change the name of this method, so instead of main, maybe we made a typo and we put mate. Now when I try to compile, okay, it says operation complete. So it compiled because I can have any name I want for a program. So that's not a syntax error, but when I hit the run button, it says, uh-oh, no main methods have been found. So there's no way for Java to run this file because it has no main method. So you can see that's a different type of error than the syntax error that was captured that prevented it from compiling. Okay, your syntax errors, those are called compile time errors because they prevent the code from compiling. Errors where you make a spelling mistake in your method and there is no main method, then that doesn't get caught until runtime. So that's a runtime error. Okay, so we'll go ahead and put our main method back in there. Okay, now let's say we wanted to print hello world, but we want those quotation marks to show in our output. So right now, if I were to put another pair of quotation marks in here, hoping that the quotations would print output around that hello world, okay, if you notice the hello world text is not blue anymore, right? Only the quotation marks turned blue. And that's because those quotation, open and close quotation, are indicating that what's in between is the string literal, and there's nothing in between, right? So in order to get Java to recognize that I want to output a quotation mark, I have to momentarily escape the string literal. And we do that with what's called an escape sequence, and that's using the slash. So if I put a slash in front of the quotation mark, it's going to read that as, oh, you want to print that quotation mark. Okay, same thing for the second quotation mark. If I want to, or in the string literal, if I want to print that one, I'm going to need to put an escape in front of it, and then it'll print the quotation mark there. So these quotation marks on the outside, here and here, those are indicating what's between them is a string literal. Then the slash, that's our escape sequence, tells the computer, hey, regard this next quotation mark as something to be printed, not the end of the string literal. And same for this one. So if we compile and then go ahead and run, now our output is hello world again with quotation marks around it. Okay, if I wanted to put world on its own line, I could again use an escape sequence. So I'm going to put a slash for my escape and then N for new line. So I don't even need a space there. I can just read across. It'll be hello. Then it'll make a new line because of this escape N, and then world with an exclamation point and a quotation mark. So let's compile. Okay, and then we'll run and see there's my hello followed by world. Okay, notice that in the string literal, these spaces got picked up as characters. You can see those 3 spaces in your console. Okay, the spacing is only picked up by Java inside of a string literal. If I were to remove these spaces after the quotation mark and instead insert them before the quotation mark, okay, now when I compile and run, right, notice these spaces before the quotation mark were not included in the output. Right, Java doesn't read spaces as meaningful unless they're inside of a string literal. Okay, so that would mean that I could have lots and lots of spaces, right, between my open parentheses and my closed parentheses, right, all kinds of spaces. This should still output the same thing. Right? And you can see that it does. Now that's really difficult to read. It doesn't look pretty. So generally we don't insert random spaces unless there's a purpose to it. We want our code to be clean and neat and easy for people to read. Other escape sequences you can see over here in the Java Oracle API. And these escape sequences do different things. So /t will insert a tab in the text. /b will be a backspace. Here's the N, the new line that we just played with. /r is a carriage return. And a carriage return returns the cursor to the line that it's on, but to the first space in that line, where new line goes to the next line, the first space of the next line. /f is a form feed, then slash with an apostrophe, right? We'll put a single quote, /double quote there, and then // that inserts a backslash into your string literal. Okay, so if we want to look at some other things that we can print. Okay, system out print. Oh, and here's a good distinction to make. So in our first program here, we used the print function, just print. That prints to one line, the /n, that took us to a new line, and the cursor ends right here at the end of that apostrophe, or sorry, not apostrophe, quotation mark of that line. If I were to have a second print statement, I put that in the wrong spot. There we go. So if I want a second print statement, maybe we'll have this one say goodbye. Okay, when I compile and run, because the cursor ended after the quotation mark, right, you can see that goodbye is now on that same line, right? So, oh, we had 3 spaces. Let's go ahead and get rid of those spaces. So, compile and run, and there's our hello on the first line, followed by world, then our exclamation, quotation mark, and then see how goodbye just got tacked right on beside it. Okay, and that's what the print function does. After it executes and displays that word, the cursor ends right at the end of that word. Okay, if we look at this new program, plus sign is the name of the program, because we're going to explore what the plus sign does in the print statement. Okay, now you can see that we're using the print ln function instead of print. Print stays on the same line. Print ln, when it finishes outputting what's in that parentheses, it's going to go to the next line. Okay, so let's see what happens when we output some numbers. So 5 plus 2 plus 1. Okay, if we compile and then we're going to run, okay, we can see that 5 plus 2 plus 1, it added those numbers together and output an 8. Okay, if we do this, but this time we're going to put quotation marks around those numbers. So it's still 5 plus 2 plus 1, but now remember what's inside of quotation marks is a string rather than a numerical number value. So we're going to add, we're still using the plus sign, 3 strings together. So let's go ahead and compile and we'll see if that results is any different. Okay, so here we can see our 5 plus 2 plus 1 with numbers added together to get 8. When those are strings, the plus sign, instead of adding, it's something called concatenation. So let's comment our code, and to comment we put 2 slashes, and this is concatenation. Concatenation joins or links together those values in the strings. It doesn't treat them as numbers, it treats them as text. Okay. Now let's copy this and we'll paste it, and let's remove the quotation marks around the 5 and the 2, but we'll leave the quotation marks around the 1. So before you run this, think about what you expect to happen, right? Do you expect it to concatenate everything? Do you expect it to add everything? Do you think it'll be a combination? So we'll go ahead and compile and then run. And we get 71. So we can see that the 5 plus 2 got added together. Those were treated as numbers. And then it changed to concatenation to tack on the string literal of 1 at the end. Okay, let's copy that line. And we'll paste it. And let's move those quotation marks. And now we'll put the quotation marks around just the 5. So now the 5 is the string literal, 2 and 1 are numbers. So again, before we execute it, think about what you expect the output to be. Okay. And most students, they expect that the numbers will get added together and that this would output 5, 3. But we can see in the console that it took the string literal 5 and then it concatenated that 2, right, onto the string. And then it treated the 1 also as a string and concatenated that onto the 5, 2, right? It joined them together. Okay, and Java will always do that. The first plus sign that it encounters that's related to a string, it's going to treat as concatenation. And everything after it will be considered or treated like a string as well. If I wanted this to add first, I could group it in parentheses, the 2 plus 1, because Java follows the order of operations, much like in your math class, right? Your calculators follow an order of operations. And that order of operations starts with parentheses. So Java is going to give precedence to these parentheses and do what's inside them first, ignoring this string literal for the time being. So now Java will add the 2 plus 1 to get 3. Then it's going to concatenate the string literal 5 with that result of 3. So we'll go ahead and compile and then run. And there's our 5, 3 that we expect. So I encourage you to keep copy pasting and playing with the different possibilities, combinations of numbers and strings, and get acclimated to what you see with your concatenation versus addition. Okay, let's go back over to our hello message. And we're going to look next at what happens with some escape sequences in different types of, different versions of Java. Okay, so I changed the print statements a little bit. I inserted some tabs, and I changed the class name to table. So if I try to compile, okay, I get an error message which says class table is public, should be declared in a file named table.java, right? Notice that the file that I'm working in still has the name hello message.java. And if you change the name of your class, you have to change the name of the file. Otherwise, there's a mismatch and it won't run or compile. So I'm going to go up here to File, Save As, and I'm going to save it as table.java in my new folder. Documents, new folder, right? There's my hello message.java. I don't want to overwrite that, so I'm going to save it as a new name, table.java. Okay, so what I have here is first I'm going to output a string of numbers in sequence, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. That's going to help us count and figure out what's happening with the tab command. And then I'm going to do 1 and then a /t. So the /t is a tab, then the word 2 with a /t for another tab, right? 3, 4, and so on. So let's go ahead and compile, and then we're going to run. And if you look at the output here, you can see that the words are being organized into columns. So 1, 2, 3, and then 1, 2, 3, and there's my second column. So I had 6 spaces here occupying my first column, and then 6 spaces in my second column, 6 spaces in my third column. Let's look at what happens if I change this word 3 to be 13, because now that's longer than the word 3. So we'll go ahead and compile, and then we're going to run. And notice now my first two columns are lined up. Third column, the start is lined up, but my fourth column, the word 8 and 4 are no longer lined up. And that's because this word 13 was longer than the block of 6, so it went out to 9. And do you see how the columns are always starting at multiples of 3? So if I want to line up the 8, the word 8 with the word 4, I'm going to need a double tab in between 7 and 8. So I'm going to go ahead and put in another escape T for tab. And now I'll compile and run. And now we can see that these are all lined up again. Okay. Now, if you're using JGrasp here at Carlisle High School, then you're running a version of Java that is very old. It's Java 8. And the AP exam also uses Java 8 as its expected version. Okay, in an online IDE, so for example, REPL is an online IDE that it runs Java 21, I believe, maybe Java 22. So in REPL, and I'm going to go ahead and delete these extra bits here that we don't need. REPL requires the class to be called main. So we're going to use main as capital M as our class name. And then our main method signature can still be the same. And then here, that's my typo. I need that to be a /t. So here's our code that we just ran in JGrasp using Java 8. Now let's run that same code, but in this newer version of Java and see how it's different. Okay, so you can see that definitely not lined up in multiples of 3. Right? Notice how the 2 and the 6 aren't anywhere close together. Okay, so let's try changing this pattern a little bit here and see if we can find what it is. Oh, what did I do there? 1, 2, 3, 4. Oh, I think I copied and pasted maybe. No, too many. Okay, we'll just stop there with that. All right, let's go ahead and hit run. Okay, so we've got 1 has 3 letters, and then it made a space, and it lined up at the next set of 4, right? Then 1, 2, 3 made a space, and it lines up the third column at the next set of 4, and then the next set of 4. So it's looking at multiples of 4. Okay. On my second row, because 5 is 4 characters long, it's going to go a whole 4 before it starts the next column. So there's 4 spaces between the words 5 and 6. Then 6 is 3 letters, so 1 space gets us to 4, and it starts the 7. 7 is 5 letters again, which is more than 4, so it's going to put 1, 2, 3 spaces to get to 4, right? And then the 8 gets output. So if I want to line these up, I'm going to need to put extra tabs in here. So if I do, whoops, wrong direction. If I do an escape T in front of my 2, that's now going to line my 2 up with this word 6. So we'll go ahead and run it and see how now 2 and 6 are lined up. Right? 3 and 7 are lined up, 4 and 8 are lined up. If I uncomment my next row, okay, now my 4 columns are still lined up. Let's uncomment that last row. And we can see now because 13 is longer, it's bumped out the 14, and now we don't have our nice neat columns anymore. So since 13 is the longest word, I'm going to need to tab over 2, 6, and 10 again. So I'm going to need another T, another escape T, another escape T. And now, see, I've got my second column lined up. But these words 3, 7, and 11 that make up the third column, they need to be over here with the word 15, right? So I'm going to leave you to play with fixing that up to get those columns to all line up nicely. But what I want you to notice primarily is the difference between how that escape sequence was treated in Java 8 versus Java 21 or 22, whichever version REPL is running right now. Right? There was a change in how those things behaved. Right? There's also a difference in how some of the other escape sequences work. So, for example, the carriage return, the /r, behaves differently in the different versions of Java. Some versions of Java will read in the /apostrophe differently than others. So just always be mindful that when you're answering the multiple choice or true false questions in your assessments, it's aligned with the AP curriculum, which is using Java 8. Okay, so don't always think that what you put in REPL is going to match your answer choices on a multiple choice assessment because the different versions of Java do different things with those escape sequences.